All right, so here's one more example, and this one's actually going to have a removable discontinuity. So we'll get to that, but this is an example that has, multiple asymptotes, intercepts, that kind of thing, but then also has a hole in it. But it starts off the same as all the other ones start. So to find the y-intercept, we plug in 0 for x. We'll get 0 squared plus 2 times 0 minus 3 over 0 cubed minus 0 squared minus 12 times 0. And that's actually going to give us negative 3 over 0. And we know we can't divide by 0, so that's undefined. So there actually is not a y-intercept on this graph. It does not ever cross the y-axis. Okay, for factoring it, I'm going to factor it up here because I don't have a ton of space. If I look at the numerator, it's pretty straightforward, right? I'm looking for, because it has a leading coefficient of 1, I'm just looking for what multiplies to negative 3 and adds to positive 2. So these are our only options, and we just need to figure out, okay, the 3 is positive and the 1 is negative to give us that positive 2. And then for the denominator, the first thing I notice is they all have an x. So the first thing I'm going to do is pull out an x, which will leave me with x squared minus x minus 12. Then I can factor this quadratic. We're looking for something that multiplies to negative 12 and adds to negative 1, which is going to be negative 4 and positive 3. So now when I write this out as a fraction in factored form, what you'll notice is that we have an x plus 3 in the numerator and an x plus 3 in the denominator. And those cancel each other out. So our factored form is actually just x minus 1 over x times x minus 4. Now, we can't just say, okay, now we're going to graph this. These are the same function. We can't just ignore the fact that we got rid of x plus 3. X plus 3 is actually going to help us find a discontinuity or a hole in our graph, right? We can also call these removable discontinuities lead to holes in the graph. And that's because if we were to, well, let's see. Let's start with x plus 3 equal to 0. We can see that our hole is going to be at x equals negative 3. And the reason for that is if you, into this original function, if you plugged in negative 3, you would get 9 minus 6 minus 3, which is 0 in the numerator. You would get negative 27 plus 9 plus 32, which would give you 0 in the denominator. Okay, 0 over 0, that's undefined. We can't have that. So that's why we had to get rid of it, because it is possible to plug negative 3 into this function, but we still have to remember that we are graphing this old function. So on our graph at x equals negative 3, we're going to graph a hole. The function's going to go right up to it, not hit it, and then continue going. So we need to figure out the ordered pair for that hole, right? We know it's negative 3 comma something. Well, whenever you have an x coordinate and you want to find the y coordinate, you just plug it in. So obviously we're going to plug it into our new one, because as we can see, when we plug in negative 3 to the original form without the thing canceled, we get 0 over 0, which is the whole reason we canceled it. So negative 3 minus 1 over negative 3 times negative 3 minus 4. Negative 4 over negative 3 times negative 7 is positive 27. So now we know when we're graphing this at negative 3, negative 4, 27, so pretty close to 0, we're going to have a point, but it's going to be an open point because it's a hole in our graph. So our function's going to, touch it, almost go through it, but not actually be a point on our function. Okay? Vertical asymptote, we find the same way as we always do. We set the denominator equal to 0, but once you, reach this step, you don't pass it, you don't go back to the old form. Okay, you start by setting, this denominator equal to 0. So x times x minus 4 equals 0. x equals 0, x minus 4 equals 0. Well, that's going to give us the vertical asymptotes x equals 0 and x equals 4. And again, we always write them as an equation because they are a line in our graph. Okay? X-intercepts, we know that to find those, since it's always, x comma 0, we set our function equal to 0. But whenever we set our function equal to 0, we're going to cancel out the denominator anyway. So really all we have to do is set our numerator equal to 0. So x minus 1 equals 0, x equals 1. But we don't write it as an equation because it's not an equation. It's an ordered pair. So it's going to be 1 comma 0 for that. And then last but not least, we find our horizontal asymptote. This actually, we haven't done oblique asymptotes yet. So you can kind of ignore that part. It's going to be horizontal. So we're in, one of three situations. The numerator is greater, the degree of the numerator is greater, the degree of the denominator is greater, or they're the same. Well, here we've got x to the first, and here we've got x times x, which would make x squared. So the degree of the numerator is 1, and the degree of the denominator is 2. So 2 is greater than 1, which means we're in the situation where the asymptote is y equals 0. Okay, so just like we did with the other problem, now we're going to go ahead and plot all of these things on our graph. So we can start, we've got an asymptote at y equals 0. We just did that one. We've got an intercept at 1, 0. Now, you may be thinking, how can we have an asymptote there and have a point on it? Well, remember, you can cross a horizontal asymptote. Horizontal asymptotes, they're just talking about end behavior. So as the function goes towards negative infinity and positive infinity, our function has to follow the horizontal asymptote. But in the middle, your function can cross it. Vertical asymptotes are another story. You can never cross a vertical asymptote because the function would be undefined. We've got vertical asymptotes at x equals 0, right? That's why we couldn't have a y-intercept because we can't cross an asymptote that's vertical. And then at x equals 4 as well. And then is there anything else we have? Let's see. We didn't have a y-intercept, but we did have a hole, and we're going to plot that because it's going to help us graph a little bit later. It's at like -3, almost 0, and that's going to be an open circle to show you that your function goes through it, up to it, but it's not actually a point on your graph. All right, so you can see I've kind of got the outline for the sign chart started here, right? It's going to be along that first column right here. We're going to put all of the factors of our function. So again, we got rid of x plus 3. So that, dead to us. We're done with it. The only reason we needed it was for the whole. But now we can put it, or we don't put it in our factors column. Okay, and then along the bottom, we do a number line. You don't actually have to draw a number line. I usually don't, but we're doing a number line here from negative infinity to infinity, and we're putting on it the places where the x-axis is crossed. And we can see that that's at 0, 1, and 4. So that's why those are our numbers down at the bottom. Okay, and now what we're going to do is we're going to go through step by step, each interval one at a time, and plug in numbers to see if the function is positive or negative, above or below the x-axis. So a number between negative infinity and 0, I'm just going to go with -2. You could do -100, -1, -0.5, doesn't matter. -2 is negative, -2 minus 1 is negative, -2 minus 4 is negative. Well, a negative times a negative times a negative is a negative. So we know that from negative infinity to 0, our function is below the x-axis. Okay, and then from 0 to 1, this one's kind of tricky. We really have no choice but to do a decimal. So I'll do 0.5. 0.5 is positive, 0.5 minus 1 is negative, 0.5 minus 4 is negative. A positive times a negative is positive. So we know on that little sliver from 0 to 1, our function is above the x-axis. Then from 1 to 4, we can plug in, 2 or 3. Again, doesn't matter. 3 is a positive number. 3 minus 1 is positive. 3 minus 4 is negative. Well, a positive times a positive times a negative is negative. So from 1 to 4, our function is negative. Then if we look from 4 to infinity, I can plug in 6 or 7 or, 100, whatever. 6 is positive, 6 minus 1 is positive, and 6 minus 4 is positive. Positive times a positive times a positive is going to be positive. So we know from 4 to infinity, our function is positive. So let's just refresh and think of all the other things we have to follow when we are graphing a function, right? Not only do we have to take into account these intervals in the sign chart, but we also need to make sure it's a function, right? So we can't have anything like this because that's not a function. It doesn't pass the vertical line test, right? And then we also need to make sure that we're following our horizontal asymptotes at infinity, following our vertical asymptotes at infinity, and then making sure we're going through all of the points. And I actually just realized I accidentally erased the whole. So let me put that back. But that is also a point we're going to have to, go through. So let me redraw that. It was -3, like -427, so almost 0. So given all this information, let's see what the sign chart tells us. So the sign chart, that was not correct. The sign chart tells us that from -infinity to 0, our function is below the x-axis. So from here to here, my function's down here, right? I can't, even though this follows all the other rules, right? It follows the asymptotes, it's a function. We can't actually put it there because that's not where our sign chart tells us the function is. It says the function is negative from -infinity to 0, which means it's below the x-axis. Okay, then, so let's just put that in, right? And we know we have to go through this point. So we have to follow both the horizontal and vertical asymptote, and we have to stay below the x-axis or below the, horizontal asymptote that whole time. So my function is going to start here. I'm going to hit my hole. I'm not going to go through it, though, and then I'm going to continue on here. Okay, and remember, it's just the best sketch you can give, right? That's what we're trying to do, is just get a sketch. But it does have to go to the hole, not through it. The point is our function gets really, really close, like -2.99999, -3.0001 are points on this graph. But right at the hole at -3, there's nothing there. It's an open hole. Okay, so if we look at the next interval, 0 to 1, and you can shade in first, but let's just take this one step by step. So the rules we have to follow here is that we have to be above the x-axis, so we have to be in this little sliver, right? And we have to follow the vertical asymptote. So technically, this follows the rules. It hits the point, it follows the vertical asymptote, but it's not where the sign chart told us our function would be. The sign chart says we're going to hit this point, we're going to follow the asymptote, and we're going to be above the x-axis. So, I'm kind of being picky with my line here, but honestly, any of those would have been fine. So there's from 0 to 1. And then if we look from 1 to 4, we're negative. So that means from 1 to 4, we're down here. Well, again, we have to hit this point. We have to go through the point. We can't just start here because we don't have an intercept there. We can't just stop the graph there, right? We start at this point and then we follow the x-axis. Now, for all of these sketching things, you just need to remember that it's a curve, right? Everything should be curvy. This straight line, not going to cut it. A corner like that, not going to cut it. So it doesn't have to be perfect, but just keep in mind that there's smooth curves. So there should be none of the, wee business. Well, that's not even a function. But, we shouldn't be curving crazy. Okay, so it's just going to be a smooth curve, remembering it has to stay a function, right? We couldn't go like this anyway. because this is not a function. This doesn't follow the vertical line test. So that's kind of how we know that that has to go that way. So there's my curve on that one. And then we have one last interval, 4 to infinity. We are above the x-axis. Now, that's really the only information we are given. We don't have any points there. So we just have to use the fact that we need to follow both of the asymptotes and stay above the x-axis the whole time and be a function, right? So we can't do that because that's not a function. That doesn't pass the vertical line test. So keeping in mind that it has to be a function, it has to follow both asymptotes, we can go like this. Again, it's a smooth curve. This technically follows those rules, but that's like a whole right angle. This is, way too straight. But, if you go like this, or if you go like this, honestly, both of those are fine. Both of those could be what it is. We're just trying to get a good sketch of it. Okay? And I'd say that's a pretty good sketch of it. So there we go. We are done. Feel free to email me if you have any additional questions about any of these examples or your homework.